Right, welcome to GSP 270. My name is Tawanda Gara. I'm your instructor for this course. Okay, the learning objectives for this short lecture are to understand first, what is GIS? Second, who is using GIS? The difference between GIS, the system, and GIS, the science. And lastly, the elements of GIS. What is GIS? GIS stands for Geographic Information Science. Let's break down each of those terms. Geographic is derived from the term geography. Geographic refers to location on the Earth's surface. This location could be absolute or relative. Earth reference location is also called georeference. In principle, geographic means we're interested in answering the where component. For example, where is high crime in a city? Information is the collection of facts, knowledge obtained from an investigation using data. So in GIS, we need geographic data or geospatial data to generate information. This could be data in form of GPS coordinates, like where crime was recorded in a city. By analyzing that data, patterns can be reviewed and crime hotspots or hotspots can be identified. System. System defines interrelated parts working together to achieve an end goal, that is, of generating information. In this case, the generated information is spatially referenced, or as coordinates. The GIS is made up of the hardware such as GPS units, drones, softwares like ArcGIS Pro, data or geospatial data, and people who operate these components. GIS basically records location of features or geographic phenomena and their associated properties or attributes. And Bostant defines GIS as a computer-based system to aid in the collection, maintenance, storage, analysis, outputs, and distribution of spatial data and information. The collection and maintenance, storage, analysis, outputs, and distribution of spatial data and information is what defines the elements of GIS. It is important to understand that GIS has been in existence for quite a long time, way before the invention of computers. In 1854, a scientist by the name of John Snow conducted pioneering investigation on cholera epidemics in England, particularly in London, in which he demonstrated that contaminated water was the source of cholera epidemics. By using maps, it was identified that a pump on Broad Street was the source of the disease, and most of the cholera events were clustered within a short distance from the pump that had begun to leak the bacteria. Consequently, the removal of the pump handle led to the cessation of the epidemic around that neighborhood. Who is using GIS? So GIS has become ubiquitous in academia and research. All disciplines from natural resources, engineering, arts, and humanities are using GIS to unveil spatial and temporal information within their respective areas of interest. From this figure, we can see that the proportion of individuals using GIS are mainly skewed in environmental sciences. However, this distribution is not conclusive and vary over space and time. Next, we need to distinguish GIS, the system, and GIS, the science. GIS, the system, exclusively refers to the interrelated parts that generate geospatial data and information. So this is your tools, softwares, hardware, and the people. The GIS science, on the other hand, explores the underlying geographic concepts upon which geographic tools are developed and used to extract information from geographic data. Geographic information science aims to create a platform for development of novel tools for data collection and data analysis in a bid to retrieve more information from geospatial data using the scientific approach. It is important to understand that in GIS we have two types of data, that is spatial and aspatial data. These two are linked and cannot operate in isolation. Spatial data is the data that describes where something is located on the Earth's surface. That is what you see on display when you open a shapefile, for example, in a GIS software. So those geometries define the coordinates. Spatial data is data that describes the spatial data. It is the data that is contained in your attribute table. This data can either be quantitative or qualitative depending on what is being described. However, it is important to understand that these two types of data, that is spatial and aspatial data, cannot operate in isolation. For example, we need to see the spatial layout of a point map in space and at the same time be able to retrieve or query the attributes of each point. For aspatial data, we have got four main types of this, that is nominal, ordinal, interval, and ratio. Nominal provides a name or an identifier of features in your map, so names of geological units, land cover, thematic classes such as grasslands and water and so forth, and that data is contained in the attribute table. Ordinal is data that can be put in a natural sequence but do not allow any other type of computations. So data set that can be categorized into, for example, low, medium, and high. So this could be elevation classified from low elevation to high elevation. Interval data is data which have no arithmetic zero value, like temperature, pH, earthquake magnitude. This data allows simple form of computation like addition and subtraction, but its incremental is not sequential. Ratio data allows most, if not all, forms of arithmetic computation and therefore the natural zero value, things like distance. For example, we know that a distance of 2 miles is twice as much as 1 mile. Elements of a GIS. So the elements of GIS include collection. So collection focus on collection of geospatial data using tools such as GPS units and measurements or observation that is spatially referenced, or data from geoportals where GIS data is stored or shared. Maintenance focus on quality control, making sure that all the standards are adhered to in the collection, maintenance of geospatial data. In most cases, information on both collection and maintenance is stored in the metadata of each geospatial data. Storage. Storage pertains to how the data is archived in folders, on a hard drive, in geodatabases, on the cloud, or on a hard, or as hard copies and so forth. Analysis pertains to how the data is treated to retrieve the information from it. This could be selection by location, overlay functions in ArcGIS. There are so many tools in the Arc toolbox that facilitates analysis of data to extract information that is important for decision making, and other actions can be instituted. Output. Output describes the results in form of maps, tables, reports that are generated using geospatial data. Distribution pertains to the distribution of the outputs through websites, web services, publications, digital maps, like Navenza maps, etc. Summarize, GIS is about acquiring spatial data through field data collection or from geodatabases and geoportals. GIS also involves evaluating the quality of the geospatial data and assessing its fitness for use in relation to the project needs. In GIS, we are mainly concerned with geometric accuracy and attribute accuracy. We'll talk about these later in the course. Analysis. GIS is about analyzing geospatial data in programs such as QGIS, ArcGIS Pro, and many others. GIS also involves creating maps, displaying information generated from analysis of geospatial data. GIS is also about sharing data, or sharing geospatial information through distribution of maps, data, and results through publications and web maps. GIS also entails documenting geospatial data collection and analysis by providing metadata describing how geospatial data was collected and analyzed. Thank you so much.